Okay, yeah. Excellent. Woo, microservices. I think this is a technical audience. I guess people here are familiar with what microservices are, mostly. Is anybody not familiar with them? Okay, apparently not. So I'm going to mention just what they are briefly, but they are, a small independently deployable pieces of software, yeah? And the beauty of them is that they give your developer teams a lot of agility. It gives them a sense of ownership because they can be deployed independently from the rest of the solutions in the department. I have had some of my best experiences in my professional career working with microservices. And things like, imagine, you build your code, you check it in, and in 5 minutes, you can have that code in an environment where testers can work with it, they can test it. Hell yeah, I like that, yeah? Or you can check it in, and within a few hours, you can have it in production. And in different regions in the world, we're talking about Asia, we're talking about the US, Europe. I like that, yeah. So I want more of that, and I want more of that for everybody. But I'm Latin, and I'm also a bit cheesy sometimes, so I like to call that the superhero feeling, yeah? That makes me feel not just like a normal developer, but as a superhero developer. You tell me I can check in and have that in production? Yes, bring it on, yeah? So imagine I've managed to persuade some of you, and you say, I'm going to use microservices for my next project. So off you go, you gather your team, assemble, and you start building. You build your microservice, it has your own small piece of code, your database, independent from the rest, you're talking to it, you exposed your RESTful API over HTTP, you deploy to production, you're happy, yeah. It all went well, you deployed in a short time span, time for celebration. And then comes your new CTO, yeah? Brilliant guy, a bit geeky, but he's very brilliant, very clever, yeah? And he gives his stamp of approval, yeah? Let's have this across more teams. We're not just talking about one team, yeah? A microservice, might be a team effort. But if you want to grow it across a department, and that's kind of the focus of this talk, it goes beyond the team effort, yeah? How can you scale this? Let's imagine this, yeah? You have your microservice there, and there's another team of developers who build their own. Yeah, your enthusiasm was contagious. They went, yeah, let's do that. Yeah, come on, let's bring everybody together. They build a microservice. And this comes a great time for your department when you say, now they're going to have to talk to each other. Now there comes the integration, yeah? Really, really good time, excitement. You are ready for the celebration. This is engineering. This happens, yeah? I'm sure we've all gone through situations like this, yeah? Where you go, the CTO is not very happy, yeah? He says, you need to fix this. You need to talk and fix it. What happens with superheroes is that they tend to be a bit opinionated and maybe a bit sensitive about their work, yeah? I'm a developer. I am a bit opinionated. Maybe not as much as other developers, but I am very sensitive about my work. What happens when you get two teams of superheroes, opinionated, and put them together to talk? Talk, fix it, fix the problem. Yeah, the communication doesn't necessarily flow in the best of ways, yeah? Maybe some mediation is needed. And turns out the CTO has a bit of an anger management issue, yeah? We didn't know that. Okay, so it's obvious, we need to talk, yeah? And both developers are under the pressure of deadlines, under the pressures of a project, how do we do this? How do we, remove this blocker and actually let microservices scale over a department? And we're going to see some patterns that, that we use. Most of them are technical, but the first, I would call it a pattern. We use communities of interest, yeah? By the way, I think that software, building software is not only about software, it's about the people as well. Remember, you have people, you have to communicate, yeah? Talking is very interesting, and that's why I like to call the community of interest a pattern. And communities of interest are spaces where we can discuss aspects of software development, things that are going to be common to the whole department, away from the pressures of a project and from the deadlines, and also where it's not that partisan. And how do we do it? Well, we have people who are interested in one topic, who's interested in API versioning, who's interested in the security aspects. Just, people from all the department, from different teams, you get them together outside of the pressures of the project to talk. And there is a workflow for this, which is important. You meet, you get to a draft agreement. We can do it this way, yeah, yes, no. You put it somewhere on a wiki, you share it. Not everybody's convinced. You meet again, you polish your agreement, but most importantly, at the end, you want a NuGet package. Okay, I'm assuming you're familiar with NuGet. For those who aren't, this is basically just a way to share libraries in .NET, yeah? What's the beauty of this? Because, NuGet, if you're using other technologies, you would use another packaging technology. But the beauty of this is, if all you have is an agreement and a page on the wiki that tells your developers you have to do this, okay, you've helped them reach a decision, but you've only gone so far. When you have the NuGet package, you're telling them, you have to do this, and by the way, these are all the tools you need to do your work, yeah? We're making your life easy. Thank you very much. You're welcome. And this, how do we build this? We use something that I later learned is called inner source. Anybody can contribute to this. Probably the people who were initially in the community of interest. You always have those developers who are super happy to share, to help, to get involved in other projects. There's kind of a common ownership of these packages as they evolve and they mature. And once they're mature, we don't need to touch them very much, yeah? Good, so we've had the community of interest and we meet. And now I'm going to talk about some of the technical patterns we use. I'm not going to go into that much detail, but so API versioning. Most of our APIs are HTTP, RESTful, JSON format. That's how you do things nowadays, yeah? Many ways to version them, but we've chosen to go through an HTTP header because it works. It's used commonly, and many companies are benefiting from it. Why not? But remember, do not reinvent the wheel. You're probably using a framework, yeah? Use the extensibility features. Don't try to create something out of the box. I'm going to give you a glimpse of some of the code. Don't get too hung up on it. And this is not production code. The actual production code has more defensive coding. But the idea is, in our case, we use ASP.NET Core. So this is all C#. But the basic idea is that we extend one of the interfaces offered by the framework, an API version reader, yeah? And this says, we extend we implement one of the methods in the interface. When we get a request, go to the headers, get me the accept headers, find the one that starts with this string, and the version is whatever comes afterwards. So please don't get too hung up on the details. This has been put into a NuGet package, shared with the whole department. Anybody who wants to use versioning, take this package, do it. And so you don't need to rewrite the code is there. All you need to do is, again, using the framework extensibility, just write this. Suddenly you're telling your developers, There you go. Don't worry too much about versioning. We've done this for you. Use this tool. This is how it's done. We have documentation in our wiki, sample project. It's there. Versioning is solved. We're all happy, ready to move the project to the next level. Sorry. Well, of course there are more issues, yeah? What's going to happen with authentication, guys? Two different teams working. They have different views on the authentication. And the CTO is starting to lose it, yeah? How is this going to go? We also have some patterns around authorization. This is a complicated beast. We use OAuth, which is, I don't think many people really understand OAuth. I don't understand it in depth. I know just enough to use it. And I am not ashamed to say it, yeah? I'm a feature developer. I like to develop features, to build business logic. Authentication, again, the department has given me the tools. I need to do that, yeah? So any consumer of my microservices, it could be another internal microservice, it could be an end customer, they authenticate against an identity server somewhere in our network, and the server issues a token. JWT is a JSON Web Token, and it contains information of who I am, so my identity. Yeah, I am Mariano Korman, or I am so-and-so such and such customer, and what I can do. Maybe I can read our users' database. Maybe I can modify it. Yeah, it's all contained in there. Yeah. And then when we build, what we need to think about as feature teams, when we're building a feature, is what kind of permissions are the consumers going to need for this? Oh, this is an endpoint where we read, so all we need is, for instance, read users. Oh, this is where you are actually modifying information. Maybe you need the right configuration scope. We need to think about this, and we have all the tools given to us in our packages. A little bit of code. Don't get too hung up on it. This is the kind of code you need to configure OAuth using the MVC core framework extensibility. So we are defining a policy here. This is all in the initialization code when we launch the application. Our policy is called public. We are requiring the interactions read scope, and we're requiring the claim account ID and some boilerplate code to have it working there. So now any endpoint can use this policy to say, hey, you have to have these to be authenticated. Yeah? And this is all a layer of abstraction on top of OAuth. And this is how we do it. Assume this is my controller where I can see all the interactions. All I need to do is add this. Yeah? This is all leveraging the framework extensibility features. Probably some of you have already done something like this in different frameworks. This is not cutting edge technology. We're not saying, wow, this is something you have never seen. You probably have seen this. But what we do here is we take the decisions as a team, as a department. We write them down. We put things in a NuGet package, and everybody can use it. Easy peasy, yeah. So we go to production, we've solved issues like versioning, authentication, these things work, and it starts to have more load. And when the load starts increasing, you have the best kind of problems you can have, right? Yeah. You have two microservices talking, load gets too high, what can we do? CTO is not happy, yeah? One of the patterns, and this was possibly the biggest one, that was the hardest one for us to get our head around, is move from the HTTP request, hey, do this for me right now, to messaging. With messaging, you decouple the microservices in time as well. But you kind of invert the logic. Instead of saying, do this for me, you said, this just happened. Yeah. This is how you would rewrite this communication. Your microservices publishes an event saying, this thing has just happened. And this is what we call a publishing topic. And since we use Amazon Web Services, this is SNS. And the other microservice who's interested in that says, okay, I want to listen to that. And this is, I have a message queue that subscribes to that topic, so a copy of that message, of that event is put in my queue, and then I can read it and process it. Of course, there needs to be another way of sending the communication back. So you need to re-architect or re-engineer that link, but suddenly, if this service is under a lot of load, it will eventually handle the messages at its own rate. Yeah. This pattern is a bit more scalable messaging, because if there is another microservice interested, all they need to do is subscribe to the same queue. Nice. But now you're giving your developers a bigger problem. It's like, cool, it's a nice pattern, but this is much harder to write. You know, I need to provision this in production. And then I need to give my microservice the permissions, yeah? And I need to provision that and the subscriptions. You're making my life harder. I just want to build the business logic. It's okay. Yeah, the pipeline team have us covered. And we're soon going to interact with Rui's presentation. If you were here for Rui's presentation just before, this is kind of the same topic, but covered from the other side. We'll go there. All of this is provisioned to us, for us, by the pipeline as infrastructure as code. So suddenly you're telling developers, relax, guys, I know you're superheroes, and sometimes you're too passionate about your work and you express it with a lot of passion. We're going to make your life easy. We're going to deploy this. You just do what you're best at. You just build the business logic. So we have a very powerful pipeline that will do this for us. Yeah? This is what I just said, but with words. But we use Terraform. We use a tool called Terraform to define all this information here, all this infrastructure as code, and Terraform will push that as to production. What does this look like in the world of infrastructure as a code? Very simplified. Again, this is not exactly production stuff. I've had to change names and so on. But look at this. This would be metadata for the microservice. This says, this microservice is consuming a topic called interaction ready for transcription. So this automatically creates a subscription to that topic. And it's publishing to this other topic, interaction transcribed. This is the root back. This is the way for kind of the blue microservice to call back saying, hey, I have transcribed. Yeah. This defines extra policy names. So basically, you can define permissions to other Amazon resources in policies, and you reference here. Again, you're kind of saying developers, yeah, we've done this job for you. Yeah. Another thing worth mentioning is that one of our patterns is each microservice has its own SQ. So whenever we push it to production, the queue will automatically be provisioned with a microservice. And needless to say, the code to push here or read from here, you guessed it, it's in a NuGet package. So it would look something like this. Yeah. Don't get too hung up on it, but again, we go to the message client, which is the object that does this, and we register a message, a callback. Whenever you receive a message of this type, run this function. Now look at this. We try to do something with the message, we process it, and if it's also okay, we return true. Returning true says, message has been processed successfully, take it out of the queue, bye. If something fails, we'll return false, and this is all done by the NuGet package. The NuGet package knows that if you return false, there was an error. There was a temporary error, like the network was down, a required dependency was down, and the message will be put back into the queue to be reattempted, and it will be read later. And then you say, hold on, we're not just communicating to services. This is building a retry mechanism, right? Because if my dependency is not ready, I return false, the message goes back to the queue, and it's going to be retried again in 30 seconds. Also, I don't have to build a retry mechanism. I don't need to use poly or anything like that. Cool. I like that. We're in production. It's working now. We have solved our scalability issues. We have a happy CTO. And he has a pep talk, a congratulations, celebrate talk for the whole department. Yeah? So now let's talk about something we didn't quite mention much earlier. Deployment, yeah? We're in the world of superheroes here. And we know that superheroes, there's the philosophy. With great power comes great responsibility. Rui talked to us earlier, if you were there, about the pipelines and how we let developers deploy, yeah? So it's very tied to this. Assuming that you're a group of superhero developers and say, right, you're microservice, you're independent, you deploy to production whenever you want to. Me? Really? That's boring. That's repetitive. And if I have to deploy every day, it's going to be very boring. How superhero is that? I'll tell you how superhero it is. It's this superhero-y. Does it look like a superhero to you? No. What happens when you have superheroes doing manual repetitive work? Do you want your superheroes to go and work for the competition? No. So, some piece of CTO wisdom. I told you he was an intelligent guy, yeah? It's true. We shouldn't have developers. Developers are creative people. They want to build solutions. They are inherently motivated by saying, hey, yes, look what I've done this, yeah? They are not motivated by saying, I'm going to do this over and over. So automate it. Automate what you can, yeah? Give them all the tools. And this is where the pipelines come in. We've talked about superheroes. Let me talk to you about my favorite superhero, really close to my heart. And this is Super Lopez. Yeah, you probably don't know him because he's a Spanish cartoon superhero, obviously a parody of Superman. Yeah, he can do anything that Superman can do. He can fly. He's super strong. All of that. But there is one catch. All his superhuman strength is in his suit. If he forgets his suit in the dry cleaners, something like this happens. And I think this slide doesn't need any translation, right? You can understand what's going on. Again, I'm a bit cheesy, but I would say that my superhero suit is the pipeline, yeah? Thanks to the pipeline, and something that what Rui was talking to us about earlier, that's what gives me the power to say, yeah, I can do this, You report back to me in the morning, we start working on it, and in the same day, it can be pushed. If it's a not a very complicated bug, it can be tested, blah, 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 pushed out and fixed all over the world. That is all thanks to the pipeline, yeah? What does our pipeline do? Well, it does the basics, of course, the essentials, yeah? Continuous integration, deploying with one click, so you push a button, and your software goes to production. If something went wrong, you can roll back by pushing the same button you pushed before to roll back to the previous version, yeah? Something we do in our platform is we don't reinvent the wheel, we leverage platform as a service. So we use AWS, you might use Azure, you may use Google Cloud, yeah? AWS is our choice. So if our microservices are Docker container, which they are, we push them to ECS, Elastic Container Service, which is Amazon's way of hosting containers, yeah? And as Rui mentioned in his talk earlier, we have pipelines for the pipeline. That's what I call the meta pipelines, just because the word meta is really cool. And what it means is you don't want, you have a new microservice. You don't want your developers to go and configure your Jenkins server to other pipeline, because you shouldn't trust developers. I know I am a developer, right? So, and what you don't want to do is having to be, as Rui said, the pipeline team does not want to become a bottleneck. If you have to go for them, hey, please build this pipeline for me, they're going to be annoyed, yeah? And we're going to be annoyed because we're going to have to wait on them. So basically what we do is we create a file that defines our build. The file says, this is where my code lives, and this is where my, this is the environment I want to deploy to. You check that in, magic happens, and a few minutes later, you have a new build configure that will be able to build and publish your code. I've just pushed a lot of information onto you, yeah? So let's try to take a step back and reflect a bit. The bits in green here are owned by the feature teams. This is the code, this is basically the business logic. At the end of the day, this is what the product owner, what product wants, the business logic. This is the environment config that says how all of these will be, all the configuration for the different environments. And it's in green because it's owned by the feature team. Yeah. You have the NuGet code that implements those features, some of those features we spoke about earlier, and that has a collective ownership from the whole department. And the you didn't see any of this. The pipelines are owned by the pipeline team, and finally the production environments that belong to ops. You don't want developers having fun here. They will have too much fun. And on top of this, we have this little funny thing, which is the NVM CLI. So the NVM CLI is a command tool that, amongst other things, helps you provision all of this. So the NVM CLI is a code generation tool. I am doing a gross simplification here. Say, NVM CLI, I'm creating a new project, and it's going to be a .NET microservice. Sure. It creates a pipeline project for you, as we said earlier, which you check in and automatically creates a new pipeline, creates a basic environment config with some properties that we have by default, and a scaffolding for all the Dockerization of your microservice code. There you go. You can start. And now we see that all our microservices share something in common. They share some common DNA. If they've all been done with the NVM CLI, they all share the same structure. There is some standardization, yeah? In English, we would say they're cookie cutters, because you cut the cookies with the same cutters. I'm cheesy and we're in Poland, so is they like pierogi, yeah? You've got the different pierogi there, and it doesn't matter whether Russian pierogi or whatever you put in them, they all still have done part. The content may be different, but you've got them using the same tool. This gives us standardization in the department. And that has a lot of advantages. Imagine you have, a superhero developer who's experienced in already microservices, and she says, I'm ready for a new challenge. I want to join another team. I want to work in a different part of the business, or in a different feature team. I want to join another feature team of superheroes who do good code. Yeah, okay. Dev managers make that happen, but there's going to be less friction, fewer barriers to get there, because she already knows how the microservice stuff works. These people are working the same way with microservices, deployment, builds, and so on. So there is perhaps one final barrier for this standardization and this moving between teams, and that would be the programming languages, because that's something that fragments our craft a lot. You may be a great developer, but you only do Java. Maybe you're not going to be as effective if you join another team. And this is a very fine balance that, the company, that's above my pay grade, many times above my pay grade. But there are decisions that you need to make. It's like, what languages you support? Because on one hand, you want to let your teams be creative and build cool stuff. And some teams are really motivated by experimenting and trying new languages. And on the other hand, you want to standardize to make people easily movable between teams, yeah? So as a company, we have decided that less is more, and we're focusing nowadays on only 2 programming languages. And these are our 2 programming languages. Yep.
You're missing Ruby there. It's just you.
Hey, it's only 2. Yeah. Don't go crazy. So nowadays we're focusing on .NET and Python, and obviously these are historically, they're there for historic reasons. Some of them are the best language for the job they were doing, like our API gateway deals with low-level constructs like HTTP packets and so on, and Go apparently was very good for that, or so they tell me. I have no clue. Others are basically because of the talent we had in-house or teams wanting to experiment, yeah? There is a challenge. We have other patterns as well. We're getting close to the end of the presentation though. I don't want to get into too much details about these patterns. You can ask me any questions you want about them or anything else towards the end. Suffice to say that we have made decisions as a department around them. Some of these have been created as NuGet packages. Some of them have been put in part of inside our pipeline. And basically all of these is, we know whenever we start a microservice, we already know how we're going to address all of this. Yeah. And they are all important actually, because you need metrics to know what's going on inside your microservice. You need logging for issues like supporting production and so on. Now the journey isn't over. There's still a long way to go. Yeah, but I think we're in a really good position. These are the kind of things that we want to do in the future. Yeah, I've spoken to people who are in charge, to architects or people who are in charge of the pipeline, and this is where we want to go. Maybe I'll be talking about this next year. Yeah. So I wanted to wrap up, and what I wanted to say is, remember. What feature teams are really good is at building business logic. Yeah, that's what makes them tick. That's what they like. So if you want to have happy superhero feature teams, make the job easy. Use as much automation as you can. Give them all the patterns, the tool they need to work, and give them the freedom to work and work according to their values. Some teams are going to love things, they're driven by technical expertise. They want to be the best technically at what they do. Other teams want simplicity in their solution, elegant, a solution that's only as complex as the problem they're trying to solve and no more. Other teams like to have an environment where everybody's heard, everybody has an equal weight, and all their opinions and their voices are heard and implemented. So whatever drives them, just let them work the way they want, and they'll build great software for you. Thank you very much.